in the laboratory. 1 minute. Now, before that, okay, so are you getting this?
Yes, sir.
Okay.
Yes, ma'am.
So we had mentioned about the various ingredients. That is dry silica sand, then moisture and additives binders. So all these are mixed properly to prepare the molding mass. So before discussing the properties, testing of the properties, quickly you just consider this point, that is conditioning of the sand. It is nothing but the preparation. That is first step. What is the first step? To remove all foreign materials, including dirt, dust, nails, fins, any hard sand or larger particles, okay, waste leaves, cottons, all these, because that is mixed. So using riddle, what is known as riddle, screen, okay. So remove all these foreign materials. Then second step is mixing of the ingredients. What are the ingredients? Proper amount of dry sand, additive binders, okay, clay and other additives, clay as a binder, other additives if any, and mixed with water. And how it is mixed in a muller, or what is called a dump box or muller. That is nothing but a box where all the ingredients will be mixed. May have a rotary motion also. You are familiar with the preparation of the concrete in case of RCC casting in house construction, civil construction. So
Yes,
a
sir.
drum is there which is rotating with some constant speed, and the ingredients are placed inside. So that is like that muller. The muller is a device which kneads, rolls, and starts the sand. And in the third step, the sand is passed through a mechanical aerator to separate sand grains into individual particles. So this is for good casting. So this is a muller. That is a mixer actually. Muller blades and all these. So don't worry, there is a system. And if we use machine, then some other machines. So different type of machines are also there. So okay, from here we shall discuss some desirable properties of sand, molding sand. Okay, how the properties are measured. Now, first property may not be first or second, but as we have mentioned, porosity or permeability is very important consideration. Where porosity or permeability is the measure of openness or voidness. So that's why we are starting with the testing of grain fineness number, and this porosity or voidness or openness um, can be achieved by various sizes, as we have mentioned, size and shape. So in considering this test, we don't consider the shapes, that is geometrical shape may be anything, we don't consider that, but sizes are considered here. Now, this grain fineness test give you a concept of GFN, grain fineness number. So I am writing here. So grain fineness number, that is grain fineness GFN. So GFN is to be calculated. Now, this grain size, that is nothing but the size of the grain, is determined by the grain fineness number, that is GFN. Now there is a sheep shaker. Sheep shaker equipment. This equipment is called a sheep shaker, and this is a columnar structure, vertical, and there are number of trays. Number of trays. All these are different trays, and on the top you can pour some amount of molding sand, say 100 gram. 100 gram basically standard, or you may place 50 gram, which contains different sizes. Shape we are not considering, sizes, very fine powder, some medium coarse particles, some larger particles, and all these. And the particles, that is a dry, you take some sample mixed with clay and water. So first step is to remove all the dirt, dust, clay, and water. So clean, dried sample sand. So clean, dried, mind that, clean. So when you are cleaning, the clay content will have to be reduced, will have to be removed. So all the foreign materials will have to be removed. So clean and then dry. So when it is dried, then there is no water content. So clean and dry sample sand is placed on the topmost sheep, right? This is a
Yes.
sheep. Sheep means containing number of trays. Okay. And in different trays from the top to bottom, you just topmost sheep or tray contains some fewer number of openings. Say if this is the sheep, then this is the white space. Now here, say only the top sheep are having only 6 openings. You just observe a mesh. Mesh means 6 openings. So here the compartments are very large. So what is the advantage? If very larger particles are there, they will be arrested here. But smaller particles, all the smaller powdery mass, all these will pass through the net. So they will come to the second tray. The sheep size of the second tray is 12. It means the second tray is divided into, so this is 6, so this is further divided, so that there are 4, 4, 4, 12 such sections. So what does it mean? All the sheep sizes are standard. Say diameter A. Diameter of all the sheep is say A, and when A is divided in 6 compartments, the openings are more. When it is divided in 12 compartments, the openings are gradually reducing. Similarly, in the third tray, there are 20 divisions, 30, 40, 50, 70, 100, 144, 200, 270, and finally, all the particle, so all the particle will pass through the different meshes, and comparatively larger fragments will be arrested in different trays. And finally, the more fine powdery mass will also cross the last mesh, that is 270, where it will be stored. It will be stored in a pan. Pan means the one tray which will collect all the remaining powdery substance. So some handful of sample, that is either 50 gram or 100 gram, uh, they will be cleaned and dried, and that clay-free dry sample sand will be placed in the topmost sheave or coarsest sheave on the top, and the total apparatus will be shaked. This is a sheave and sheep shaking machine. So there is an arrangement of shaking. So there is a motor. You just observe here. There is a motor. Okay, by virtue of this motor, the total arrangement can be vibrated for some time. So vibrate thoroughly. Vibration means uh, you are ensuring that no particle are storing in different trays. So after say 15 minutes of shaking thoroughly, you collect all these trays can be collected. Okay, so collect the you take out this tray and measure the quantity weight in a balance. Okay, how much amount, because 50-gram sample had been placed, or 100-gram of sample had been placed over the top, and now all these samples are collected in each and every tray. Depending on the size, they will cross the net, and finally those finely powdery mass, they will also be collected in the pan. So measure all the amount, quantity in weight percent. Okay, so this stand now, these meshes, there are some 11 racks, 6, all these are standard: 6, 12, 20, 30, 40, 50. So this is given by some standard institutes. Now insofar as American Society of Testing Material is concerned, ASTM society, they introduced this standard of mesh sizes. But in other British system, maybe some 10 plates may be there with some different other sizes. So during the conduction of the test, you should mention the standard. Okay, concept is same, but depending on the different standards, the number of strays and number of apertures are different. Now aperture means this is the opening. Okay, the sheave with maximum mesh number has largest aperture. Sorry, minimum mesh number, and minimum is, that is 6. Okay, so now this is a procedure. The sample of sand first washed to remove. This is important because again I shall ask you something. So this is washed and remove clay from it, and then it is dried. So a weighed quantity of this sand is now placed on the top sheet, and the whole unit is shaken for definite period, mainly 15 minutes, with some vibrator, electric motor, chip shaker. Okay, and then sand in each sheave is collected and weighted. So to express in terms of some percentage of the original sample. Now the percentage, here it is important, the percentage retained in each tray or sheave is then multiplied by one multiplier. Now this is given by the standard institutions. There are some specific values of the multipliers against each sheave. Now, if you ask me how this is coming, it is difficult to answer, because the standard organizations, after conducting so many things, experiments, they have decided that this tray should have a multiplier of this tray should have a multiplier of this. So we don't know what is the basis. So we should follow the thing. Now, what is the concept? Say, this is as per American Foundry Society, AFS, as I was telling, American Society of Foundry. So they introduced these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 meshes or 11 sheaves. Finally, a pan. And corresponding to each sheave or tray, there is a multiplying factor. For 6, this is 3. 5, 10, 20, 30, 40, 50, 70, 100, 145, 200, and for pan this is 300. So these are the multiplying factor. So they recommended. So you should follow this thing. So how it is utilized? Say you have collected some sample, and in the trays say 40, 50, 70, 100, 140. Say 40, 50, 70, 100 and 140. Now you may ask, so in these trays, some samples have been collected, but in the other upper trays or in the lower trays, no sample has been arrested. It means the particle sizes are such that they are arrested only in these trays. So there are no larger particles like this and no finer particles beyond this. So all the particles are having on an average these dimensions. So they have been arrested in these trays. So that's why we are considering only these shapes. So in the 40 sheep size tray, you just observe multiplying factor is 30, here 40, 50, 70, 100. So we are utilizing this, that is 30, 40, 50, 70, 100. Sieve number this, multiplying factor this, and percentage retained. In 40 sheep tray, only 2.495 percentage of the sample sand has been retained. In this tray, 13, in 70, majority, in 100, 6 point this, and in 140, 2.49. So this is the retained sample percentage in different trays in gram. So now, sorry, this is not percentage, this is written in gram. In gram. So what is the percentage? If it is 50 grams, so if it is not mentioned probably. So say for this, say for example, this is out of 50 gram. Out of 50 gram, this is written. So out of 100, that is, we should convert it into percentage basis. So out of 100, you multiply this by 2, so 5, 28, and so on. Approximately. Or you may take the exact value, no problem. না এই শিব নাম্বারটা মনে রাখতে হবে, শিব নাম্বার আর করেসপন্ডিং মাল্টিপ্লাইং ফ্যাক্টর উইল বি গিভেন, but you should know the use, because grain fineness number, this is the formula. How grain fineness number is given? This is given by total product divided by total percentage of retained sand on the sheep, that is summation MIPI by summation PI, where PI is the retained percentage in each tray and MI is the multiplying factor. So summation MIPI by summation PI. So that is the formula. So how that is utilized? You make summation MIPI here, 30 multiplied by 5, 150, 40, 20, this is, okay. So this is total MIPI, and total retained percent is coming from here, summation PI. So that divide this. So GFN is what is the meaning? So that is the question. Now, before that, you tell me, I told you we are taking, the problem is not given, but I am telling you, we are taking 50 gram of sand sample and testing for GFN. 50 gram, mind that, 50 gram. So when the retained percentage is summed up, it is coming as 49.9. Why? Where is other point 1? So you should observe very carefully what I told you. The sample is washed to remove clay and also dried. So during washing and drying, this 0.1% has been lost. This is due to presence of clay and water moisture content. So this is the dry sample. That's why this is 49.9. And what is the meaning of this parameter, that is GFN? Actually, the standard mesh size is having a diameter of 208 millimeter. This is a standard mesh sheet, 208 millimeter. And if mesh size or sheet size is 6, it means this standard diameter is divided in 6 compartments. If it is 12, it means that this standard mesh size is divided in 12 compartments. If it is 40, then this standard mesh size, that is 208, is divided in 40 such compartments, and so on. So if it is 300, then it is divided in 300 compartments. So when I am getting a grain fineness number 51.50, it means there is no such sheep, but it indicates, that is one conceptual. It indicates that if we can divide it, we can divide, it is not there, it is not a standard, but if it were there, that is standard mesh size 208 were divided in 51.50 compartments. Okay, then all the sample sand would pass through the net. That is not an average. Okay, so this is the meaning. So if I obtain a grain fineness number of 108, what does it mean? If I ask you, what does it mean? Because there is no standard, 108 is not there. So what is then meaning? This is also not average size, but it means that if the standard sheave of 208 millimeter diameter were divided, that is a conceptual, were divided into 108 compartments, equal compartments, then the handful of sample would exactly pass through the net. So that is the meaning. That is a conceptual. So this will give you the indication of the sample size. If it is more, what does it mean? The finer the particle size. If it is less, it means the coarser the fine. Accordingly, you can understand what will be about the porosity or openness. So accordingly, you may utilize your, you may prepare your mold accordingly. What will be the exact definition of grain fineness number? তো সেটাই তো বললাম যে একটা গ্রেন ফাইননেস নাম্বার ইন্ডিকেটস that if a standard mesh size of 0.208 millimeter were divided in that equal number of equal space, then the total sample would just pass through that net. Not average. What I am telling time and again, and you are making that same mistake. This is not that simple average, so you should not utter that term. This is something else. This is multiplied with some multiplying factor. Is it average? This is not the average. This is GFN. So next test is the hardness, test for hardness, that will give you the strength. So hardness is simple thing, because you also know how the hardness for metal are tested in laboratory using hardness testing machine. That is, say if that will give you the measure of indentation. Say this is a sample surface. Sorry, this is the surface of the specimen. And if I have some indenter, okay, indenter, and apply pressure from the top, apply pressure, having one bluntage, the indenter must have some bluntage. So apply pressure. So this surface will be indented, will be depressed. Is not it? Now, if you have a steel, And if you have a, say, rubber, whose indentation will be more? Obviously, for rubber material, it will be indented to a greater extent compared to steel. Or if you have a stone, the indentation will be something. So this measure of the indentation will give you the measure of hardness. The softer material will be indented to a greater extent, whereas the harder material will be indented to a lesser extent. So that is a measure of indentation. And the instrument that will give you that measure is the hardness tester machine. And here, in case of sand testing, we use a hardness testing machine which looks like this one. There is a dial, and this is the machine all about altogether. There are various, you know, these levels. So don't worry about the level. Various switches and knobs, all these. A platform is there, and say if it is hydraulically operated or pneumatically operated or mechanically operated, actually you must apply pressure on a sample. And there are some hand tools also in the laboratory. In sand testing laboratories, we may also use some hand tools where there is a spring operated device, and there is a steel ball indenter. Steel ball indenter, what is the size? Is 5.08 millimeter or zero point 0.2 inch. Steel ball indenter, 5, this is a standard, 5.08 millimeter or zero point 0.2 inch diameter of that steel ball. Okay. And there is a spring loaded system, and you may apply pressure manually. So place this device, place this tester on the surface of the sand sample, prepare a sand sample, and place this device and apply pressure manually. So obviously harder mass will be indented to a lesser extent, and the softer will be indented to a greater extent. And this in the curvature, actually this radius of curvature, you will have to measure, but you need not measure. That device is calibrated, already calibrated. So one pointer will rotate, and this rotation reflects the radius of curvature, where radius of curvature again depends on the pressure. So from this pointer, you may have the direct reading. Some approximate values, and this will be given in kg force per square centimeter. To indent, to apply a pressure, to indent to a particular extent, how much kg force is needed per square centimeter. So compare different samples, and uh, you may have some idea which one is the softer, which one is the harder, and all this. And approximate values, say soft rammed sample, ramming pressure is very little, mild. So in hardness may be 40. Medium rammed maybe 50. Hard rammed 70. More pressure is needed to indent. 70 kg force, 50 kg force, 40. So this is hardest, harder, softer. So this is the meaning. So see, this is hardness testing. Next, another important, very important, again, we have mentioned time and again that porosity or permeability is very important. That is voidness, openness. Because gasborne or airborne defects are many more. That's why we have mentioned about grain fineness number. Again, we are discussing another concept which is also associated with this porosity, openness, voidness. So what is that experiment? Is permeability test for permeability. So where permeability is measured by the quantity of air, amount of air, volumetric quantity, that will pass through a standard specimen. Standard, obviously, you must prepare a standard specimen. Okay. Now, what is the standard specimen, it must have a cylindrical structure, short cylindrical structure. Standard test specimen for permeability test is nothing but a short cylindrical specimen with 5.08 centimeter here, 5.08 centimeter diameter, this diameter, and 5.08 centimeter high. Okay, 5.08 by 5.08. So that is a standard sample. So how this is utilized? This is the device for permeability testing. Now there is now this specimen, that is this cylindrical, short cylindrical specimen here. This is the front view. If you go through the top view, this looks like circular. So this specimen is held in a specimen holder. So this is a chamber where this is very important to note. During drawing, all of you, almost majority of you, make this mistake. That is, when you are drawing for permeability test apparatus, you are not drawing this cap, that is top lid, but this is a concealed chamber. No atmospheric air should come, or no gas from inside should escape. So upper portion is concealed, and there are two stand, that is a specimen holder. This may be a glass apparatus, and also, as I have mentioned, this is a concealed chamber, so no atmospheric air should enter inside, or no gas or bubbles should come out. That's why these stands are placed on a mercury seal. Okay, there is a pot, open pot, and stands are placed here, and it is filled with mercury. So this is a concealed chamber. And how it is used? Say, air quantity, measured quantity of air is entering here to a regulator. Why regulator? We can control the pressure control, volume control, all this can be controlled. So there is a meter through which the air is entering. Then it is coming to a volumetric gas meter, because we have mentioned we are uh, feeding some controlled quantity of air. So volume is measured, volume is known. So known volume of air. So we can control the knobs, adjust the knobs to govern the volume. So that air is allowed to pass through this duct. Okay, and it is entering through this open portion to this chamber, and it is facing one specimen of sand sample. So I am also supplying pressure regulator. So this is pressure regulator. So controlled amount of air, that is volume and pressure, both volume and pressure. I know the pressure and volume. So same air, say this is sample A. Okay. Another sample we have prepared is B. So many samples. So first I am placing sample A and allowing some controlled air to enter in this chamber. So by virtue of this pressure, some air will enter in this specimen, and there are void space, opening, porosity. So some amount will come out here also, and some will be reflected through this surface, and they will enter here, and they will pass through this duct, and there is a pressure manometer. Again, there is mercury. So this retained or the total air which can't enter inside this chamber, they will be reflected, and they will apply pressure here also. And there is a timer, so we shall observe the time, how much time they are taking. Now tell me, say if this openness of the sample, that is porosity of the sample, is very high, that is void spaces are many more, then almost the total air will escape and they will be retained in this side, and very little amount of air will come. So they will apply pressure on a very slow rate. So to achieve the desired pressure, more time will be needed. On the contrary, if this is a very solid mass, then almost very little amount will enter, can enter inside, but majority of the air here will come to this branch, and quickly they will make this pressure manometer to be achieved, make this target to be achieved. So time will be very slow. So only unknown parameter is time, because we are feeding known amount of amount means quantity as well as pressure, volume as well as pressure are known. Samples, standard sample sizes are also known. So only unknown parameter is time, how long it is taking. So from a formula, permeability number, say permeability number is given by say capital N or capital Q or whatever. This permeability number is given by this formula, where V, capital V, is the volume of air. We are feeding controlled amount, say standard, this is a standard, 2000 cc. We have one regulator, volumetric gas meter, so we can feed 2000 cc. H, height of the sand specimen, we know standard sample height. P is the atmospheric pressure, 10 gram per square centimeter. We can regulate to the pressure regulator. So that is also standard. We are feeding the same known quantity, known pressure, air pressure 10 gram. Small a or capital A, cross-sectional area of the specimen. Now, if my specimen looks like this, okay, so what is this diameter? 5.08. I have mentioned standard sand sample. So what is the area? Pi r square. Pi r square. So from this is diameter, this is diameter. So you may calculate what is the area. So this will be equal to pi r square or pi d square by 4. So 20.268 square. That is also known. So only T is unknown. Time for 2000 cc air in minutes. So time, how time is known, that is from the timer. Okay. So now, as all these are known, V is known, H is known, P is known, A is known. So if you put all these values, that will be equal to 3007.2 by time. Now say permeability number N is equal to some constant 3007 by 2 constant by this time, where constant is known. So now say 3007. So if your time is 100 seconds, sorry, then what is the permeability number? 30 approximately. Okay, 30 say. Now if your permeability time is 10, what will be the permeability number? Okay, 300. Now what does it mean? So if permeability number is more, what does it indicate? Less time is required. And less time is required means denser is that structure, because quickly the air, quickly all the air is reflecting back and quickly it is applying pressure. So more permeability number means denser the structure, and denser the structure means the particle sizes are fine, is not it? fine particle, because if the particle size is very fine, then and only then structure will be dense. So now you depend, decide what is your requirement, whether good surface finish is required. For that, finely powdery mass is required, or the casting defects are to be minimized. Then you may decide accordingly. So permeability number will give you some measure of the openness or the sizes of the grain. Another measure is strength. So one is hardness. Hardness will give you the resistance against indentation. But another strength aspect is also to be considered. And both uh, here, insofar as the strength is considered, both compressive strength, compression strength, that is compressive force. You know what is compressive force? Okay, if say this is sand sample, pressure is applied from all the sides, so that is a compressive force. So to withstand the external pressure like this, you should measure. So there are two such jaws. So this is an instrument where these are the jaws, and this is a spring operated, say, device, hand wheel, and some dial indicator is also there. So you apply pressure, so this will be reduced in volume, and accordingly we can find out the strength, how long they can retain their shape. And tensile, compressive strength, tensile, that is, the load is now applied not in this direction, a tensile force is applied in outward direction. So again it will tear after some time. So how long it can withstand? So yeah, accordingly we can measure. And some shear is also important. Shear means the it is force is applied from this end and that end, that is, it will just shear. So both shear, compressive, tensile strength can also be measured. And most likely you are also familiar with the material testing laboratory, where impact testing, tensile, compressive testing, all these are going on. Fracture. Similarly, the strengths are tested, but before that, all these samples are to be prepared following some standards. Now, moisture content test. What? এটা হ্যাঁ, এটা হ্যাঁ, কি করতে হবে? মার্কারি সিল, ওই তো বললাম এখানে। if say I have mentioned the air is entering here, okay, and it is passing through this passage. If it is very open space, then majority of the air will come to this side, and the retained amount, rest amount, will enter in this port. But if these are open, say, some air will also leak from this space, then this will not give you the actual measure, because I am sending a measured amount of air. or
Yes.
or atmospheric air may also enter. So how can you estimate? So leak is to be sealed, leak proof arrangement. This is a leak proof arrangement.
আচ্ছা, নর্মালি তো মানে মেটাল দিয়ে ওখানে ব্যাপারটা ইয়ে করে সিল করে দিলে কি হতো, মার্কারি কেন?
No, metal দিয়ে seal করলে, because I have to replace this sand sample time and again. Say this is sample A, after some fewer minutes sample B will be inserted, sample C will be inserted. So I will have to frequently, I will have to open this. If I fixed tightly, then how can it be open? Then I will have to use one lead from this top. Again, there will be some say uh, some open space. Are you getting that point?
Yes,
Yes.
sir.
That's why Mercury sealing is required. So this is a strain. Now moisture content. This is also very important. Lot of moisture will spoil your job, and lesser amount again will not serve the purpose. So what is the adequate amount? So how it is tested? 50 gram, as per one standard, 50 gram of sand sample is dried in an oven. Is dried in an oven or furnace. And by weighing the sand after it is dried and noting the difference in the initial and final readings, the percentage of moisture can be determined. Okay. What is the meaning? If you measure the, say this is W1 is the weight of the wet sample. You are taking one wet sample, green sand, where you are measuring 50 gram. So that is the weight of the green sand. And you are drying in an oven, then you are say getting some 48 point something or something, say that is small w2. So this difference will give you delta w, which is the, which is then converted into a percentage basis. Out of 50 gram, this is the difference. So out of 100 gram, so convert it into a percentage, and the desired amount is 2 to 8%. And there are other in shop floor, say in the laboratory, or not laboratory it is possible, but in the shop floor laboratory we may have oven, we may have fine weighing machine, we have time, uh, we have some expert persons, they may conduct, but in shop floor the workers are working, they don't have any time, because that is a real life situation. And also they may not be very thorough about weighing, making the difference and all these. That is time consuming also. So in the shop floor there are various instruments that is known as direct reading instruments, or also known as moisture teller. Like say some electrical instruments are there. Now electricity, when it is passing through the current, when it is passing through some water, some fluctuations are there. When it is passing through some dry space, some fluctuations are there. So some in electric moisture teller, electric devices, the current is monitored and it is calibrated. So readily you can have a measure. So whether more current is passing or less current is passing, or as accordingly the 1%, 2%, so it is calibrated in such a fashion. Or you may also use one chemical apparatus, chemical as well as mechanical. That is, say in a cylinder, short cylinder, you pour some sample, some amount of sample, then add some your calcium carbide, CSC2, and then tight the cylinder, shake well for some time, and on the cylinder there is a diaphragm containing some indicator. So the indicator will be, pointer will be shifted, it will be shifted, position of the pointer will be shifted. Why? Because as soon as you are mixing, adding calcium carbide in the sample, sample contains water. So calcium carbide will react with that water. And we know CaC2 plus H2O, readily it will react, and what will be generated? Acetylene, C2H2. Acetylene gas is very light, it will apply pressure on the diaphragm and the pointer will be rotated. And depending on the pressure of the generated acetylene, the rotation will be calibrated. And pressure again depends on the quantity of gas produced. And quantity of gas production depends on the presence of the moisture, because we are adding a same amount of acid, calcium carbide. So this is the chemical reaction and mechanical device. So chemical as well as mechanical device electrical device. So in this way, in the market, there are various ready instruments. Directly you can measure or you can guess the amount of moisture present. But all these are all only approximate values. For very good estimation, you should use this technique, weighing method. Clay content test is another important aspect because in some application you must use dry clay free silica sand for synthetic casting or good quality casting. Clay free. So what is the amount of clay? So this is also a standard. You take 50 gram of sand sample. It is dried. It is mixed with clay. Mind that. 50 gram which is mixed with clay and water. So first you dry this sample and a quantity of water-based caustic soda, aqueous caustic soda, NaOH, aqueous caustic soda solution is added. And how this is prepared, this is not arbitrarily. Water-based caustic soda solution, aqueous caustic soda solution, how it is prepared? Take 40 cc, 47 cc distilled water. In beaker, in laboratory, we have beakers, burette, pipette, all these. We have weighing machine. So you take 47 cc distilled water, again not ordinary, distilled water. And this is added to 25 cc of 3% caustic soda, 3 normal, 3% caustic soda to prepare caustic soda solution. So this is the standard. Don't take arbitrarily. And after preparation of this solution, mix the, say this is the beaker, you are preparing the solution here. Okay, this is the aqueous caustic soda solution. Now place the sand sample here. So sample containing clay, mud, all these, and using a stirrer, you rotate the stirrer to mix thoroughly. Okay, so after dissolving thoroughly using stirrer, okay, or if you have make automation, or automated system, automatic stirrers are also available. Now when the solution absorbs the clay, then you allow the mixture to be settled. So washed sand particles will be deposited here, and the upper solution will dissolve the clay and will float over this comparatively pure silica mass. So this dirty or clay, the aqueous solution containing the clay will then be siphoned off. Don't don't try to tilt this beaker in this manner to remove the liquid. In this case, again, things will be dissolved. So in this position, insert a siphon nozzle. You know what is the function of a siphon. Okay, place it in the table or top height, and placing a siphon nozzle, so this liquid will come out, this upper liquid. So gradually this caustic soda solution containing the impurities, mud or clay, will be washed. Again, repeat the process at least for 3 to 4 times. Take another fresh solution, dissolve this mass, again stir well, allow to settle, siphon off the dirty liquid, and then finally dry the sample. Weigh again and compare with the original sample. So this time, this difference will indicate the loss of clay. So this is the clay content test. Now another test is also important, that is acid demand value. Sometimes this is a measure. What is the concept? Acid demand value is the measure of alkaline solution, alkaline matters which are already mixed with the sand sample. This is not desirable. because that may spoil your job. If alkaline particle, the quantity of alkaline portion is very high, then that may spoil your job. So that is not desirable. So sometime it is measured, not always. Now alkaline matter, uh, how it can be measured. Now this setting, how it is affecting this setting property are considerably influenced by the presence of alkaline impurities, not the porosity but the setting property. So how it is measured? You take 50 gram sand sample, again a standard, and you take 600 milliliter beaker, and also take 100 milliliter of one normal sulfuric acid is added in a 600 milliliter beaker. Take 100 milliliter of one normal sulfuric acid and then heat, and this sand sample is also taken in this beaker. It is heated at about 50 degrees centigrade for 2 hours and then allowed to cool. The solution is then thoroughly filtered. Now this filtrate is back titrated. So that is a method of titration in chemical engineering or chemistry. These titrations, etc., are conducted. All of you might have this knowledge in your class 2 level. So
Yes, sir.
titration, you know. So it is back titrated using all these ingredients, one normal NaOH solution and methyl red indicator and all this and that. So from that, say, finally, we don't require this in detail because if laboratory works are to be conducted, then these will come. But you should know if theoretically you should answer some question, you should answer like this. This is the standard to be followed. And how obviously there are various difficulties. Not that simple. Burette pipette, using burette pipette, all these are very difficult. But theoretically you should write at least this. And let how to utilize this result. Say let original amount of sulfuric acid is 100 millimeter. We are taking 100 millimeter of one normal H2SO4 and 90 millimeter of NaOH is required. Where from this NaOH is coming? From this filtrate. How the filtrate was obtained? Just by dissolving this sand sample. Heating at 50 degrees centigrade for 2 hours. This caustic soda part is now dissolved in the solution. So say to neutralize this 100 milliliter of acid, sulfuric acid, we require 90 milliliter of NaOH. Then ADV is given by 10, 100 minus 90. If say 85 is needed, then ADV is 15. If 95 is needed, then ADV is 5 and so on. Okay. Now tell me which indicates the presence of more caustic soda or more alkaline matter. Higher number or lower number? Any guess? Hello?
Yes, sir.
Yes, sir.
So
If
lower number.
ADV is 5 and ADV is 50, what is the meaning? Acid demand value is 5 means more amount of alkaline matter is present, only little amount of acid is required to neutralize. On the contrary, if ADV is 50, that is alkaline matter quantity is less, more acid is required to neutralize. No, sorry, I am most likely the reverse, no?
হ্যাঁ স্যার, অ্যালকালাইন স্যার ম্যাটারটা কতটা প্রেজেন্ট আছে ওটাই তো অ্যাসিড ডিমান্ড ভ্যালু। তাহলে স্যার অ্যালকালাইন ম্যাটারটা বেশি থাকছে 50-এর ক্ষেত্রে।
হ্যাঁ, বেশি থাকলে বেশি অ্যালকালাইন ম্যাটার।
হ্যাঁ
হ্যাঁ, রাইট।
স্যার, আপনি
So
উল্টোটা
more
বললেন।
the number, more is the alkaline matter. And why it is not preferred? Because it will hamper the setting properties. So this is not very frequent, this test. So now any question on this? Because today we don't have time. So next class we shall proceed from
Yes,
the
sir.
Yes, sir.